All right, now we looked at evidence of a creator as opposed to evolution. And the evidence of a creator, we looked around on the earth. Well, how did the earth get the way it was? And we finished the last study about that. And you say, well, how did the earth get to be the way it was that we look at it today? What's the subject? How did we? Destructive power of modern river floods, right, all the way up to the main topic, physical evidence of a worldwide flood, which creates the scriptural testimony and physical evidence from earth, which testifies to a recent creation and to a creator. So physical evidence of a worldwide flood, we're down to the subject of rivers, destructive powers of modern river floods. We look at modern river floods that we have an historical reference to, and not the whole world and how the world got to us this way, and the evidence shows it's a worldwide flood. Now, other floods, local floods have occurred like modern river floods. Good thing to look at. Why? Because now we can say this is historical. We have a frame of reference that's historical from our own references historically. So let's go on down to particular area. On this area, particular Utah area, a modern flood, here it is, Utah, an account of another modern flood that's a few days old, not a few days or hours, but continuing for weeks and months. A local flood in Utah that had a huge account that resembles what could have happened way back when, just shortly after creation, a couple of thousand years actually. By the way, how do I know it's a couple of thousand years? Add up the genealogies. You add them all up, and then you go to the one in which Noah had his son right after the flood. You add all these up, only a couple of thousand years almost to that point, a little less than that actually. And that's all it was, right after the worldwide flood. The earth is the way it is today after that flood. And a couple of thousand years more, and maybe 4,000 or 5,000 years, and we have what we see today in this area of 1930 floods, destroyed houses, broke in the east wall of the schoolhouse, and deposited debris to a depth of several feet, including boulders of all sizes, up to 20 tons in weight. Some larger boulders were moved around about 1,000 feet from the canyon's mouth down a 4-foot gradient, a canyon in Utah. Several of these weigh from 75 to 100 tons each. People are able to measure this historically and figure out when it started. And two previously mentioned weigh 150 to 210 tons respectively. The deep gorges, freshly excavated in just a matter of months for the full length of the flooded canyons, are no less impressive than the flood deposits in the valley. Cuts were made in typical canyon fill in places to a depth of 70 feet. Anything that wasn't loose was cut away. What do you think about the Grand Canyon? Same thing. Everything that was loose, cut away, miles deep, a lot more water. Long continuous stretches of bedrock were exposed in the bottoms of the channels. Give you an idea. So, all this stuff in this canyon and the landfill above it gets excavated by rushing huge amounts of water, but only a local river flood, and it forms a canyon. The canyon fill consisted of debris brought from further upstream by running water and of materials collected from the adjacent canyon slopes. For many years, included were boulders ranging up to 50 feet in diameter. That river flood just took it all away that wasn't loose. What do you think what happened in the world? We have records that the entire area of the Grand Canyon, or even the Southwest, was just evacuated by huge amounts of water rushing to the tune of a mile or so, more than a mile. Now, what do you do when you have rushing waters mile high? How much weight is that? 64 pounds per cubic foot, down hundreds and hundreds of cubic feet. How many feet in a mile? 5,280. Make it a cubic, right? And have it rush through. It takes everything that's loose and leaves only thing all the way down to bedrock. That's what we call bedrock. Formation of canyons by mega floods. Amphitheater-headed canyons have been used as diagnostic indicators of erosion by groundwater seepage, which has important implications for landscape evolution on Earth and astrobiology on Mars. Perhaps any canyon study, Box Canyon, Idaho, most strongly meets the proposed morphologic criteria for groundwater sapping because it is incised into a basaltic plain with no drainage network upstream, and approximately 10 cubic meters per second, of seepage emanates from its vertical headwall. However, sediment transport constraints, 4He and 14C, 14 carbon and helium, dates, plunge pools, and scoured rock indicate that a megaflood greater than 220 cubic meters per second carved the canyon about 45,000 years ago. That's by their measurement, not by ours. These results add to a growing recognition of quaternary catastrophic flooding in the American Northwest and may imply that similar features on Mars also formed by floods rather than seepage erosion. So there you go. Catastrophic events happen instantaneously. Now we have a record, I have to look where that is, of a canyon in North California forming while people can observe it in this century. Formed in 9 hours. A mini Grand Canyon. Just like that. Boom. Matter of hours. Got enough water? Bam. You don't have to wait for long-term seepage of erosion. Goes all the way down to bedrock. Leaves nothing there that is loosed. Just a little bit of water here and there, erosion over a period of a couple of years, and then all of a sudden in 9 hours, a canyon will take it all away. Years and years and years of erosion. So you have billions of years of erosion can be taken away in a matter of worldwide flood, a matter of half a day. Geologic setting. The name channeled scablands was first used in the early 1920s by geologist J. Harlan Bretz of the University of Chicago, who made a comprehensive study of the region and proposed the idea that the erosional features were the result of a gigantic flood instead. Although Bretz's concept sparked a lively controversy, yeah, you better believe it, most geologists today agree that the scablands were carved by a flood of unprecedented proportions that took place, and they give it 18 to 20,000 years ago during the Great Ice Age. So they're beginning to show things can only be really well explained by catastrophic events. Water, mainly. The Spokane flood left its mark along a course of more than 550 miles. Now we're going greater scale, extending from western Montana to the Pacific Ocean. But the most spectacular flood features were carved into the black volcanic rock terrain in eastern Washington. This rock, the flower of the scablands, is basalt, a dense crystalline lava that covers more than 100,000 square miles in parts of Washington, Oregon, and Idaho. So, a lot of times people get their nose in the dirt and they don't get a chance to look. That's only a couple of inches or feet. They got to take a look at the wide expanse of 100,000 square miles. Same thing can happen. All the more. Oh, no. Yes. Get enough water, right? This rock, the floor of the scablands is basaltic, dense crystalline lava that covers, volcanoes. The worldwide flood was accompanied with and by and caused by volcanoes and earthquakes. The part of the lava field that underlies the scablands is eastern Washington is a saucer-shaped area of about 15,000 square miles, almost completely surrounded by mountains and nearly encircled by 3 rivers, Columbia, Spokane, and the Snake. There's some pictures here, but I couldn't copy the picture. Mars by Becky Ferreira. Megafloods on Mars carved giant canyons into the red planet. So we have Jezero crater, site of a Martian paleo lake, is on the short list of landing sites for NASA's Mars 2020 rover. Mars is currently a barren world of ice and dirt, but at one time, catastrophic megafloods of water carved massive canyons across the surface of the red planet. If you can do it there, why can't you do it on Earth? Some 3.7 billion years ago, really? Well, you measure that. When Mars was warmer and wetter, there were likely hundreds of lakes and rivers on its surface that may have supported favorable conditions for life. These bodies of water are long gone, but they carved permanent features into the Martian landscape called paleo lakes and paleo channels that scientists can study for clues about the watery Mars of the past. Now, scientists have discovered that some of these ancient lakes burst through their crater basins, causing outburst floods, also known as megafloods, which carved out wide canyons within a few weeks. Did that happen on Earth? You bet. The new finding, published by Friday in Geology. Now, geologists talk about this on Mars. Megafloods, right? Catastrophes, catastrophic events. But it all evolved on the Earth. Confirms that these flood features, called outlet canyons, were formed on very short timescales and were a major geological force in Mars' first billion years as a planet. Of course, now with catastrophic events in the picture as accepted, why do you need billions of years? Led by Tim Gouge, postdoctoral researcher at the University of Texas at Austin, researchers studied 24 ancient crater paleolakes imaged in high resolution by NASA's Mars Reconnaissance Orbiter. The paleolakes all had breaches punched through the side of their basins where water flowed into outlet canyons during Mars' early days. Now, they're still making stuff up because they weren't there to observe it. These Martian canyon patterns match existing models projecting the effects of sudden megafloods, and they also corresponded to real geological features on Earth. In particular, glacial lake outburst flows, like the Missoula floods some 13,000 years ago, left behind similar features such as the channeled scablands in Washington state. So, when Mars' lakes were confined in crater basins, Earth's glacial lakes are contained within icy dams. Megafloods on both planets occur when these structures are breached or overflow, forming similar outlet canyons. Given the large size of many paleolakes and outlet canyons on Mars, we hypothesize that lake overflow flooding was an important process for shaping the early Martian landscape, the authors said in the study. For years, scientists have been interested in landing rovers inside these paleolakes because they are among the most likely locations to find fossils of ancient Martian life. So far, nothing. Jezero crater, a 30-mile-wide impact basin that was among the locations Gouge's team studied, is on a short list of 3 landing sites that NASA is considering for its Mars 2020 rover. End of comment on the formation of canyons by megafloods. I don't have updated information. I guess I could look that up. But the 2020 rover. Take a note of that. Now I have an article, R.W. Bailey, Forestling Big Craft, Floods